Let's begin by considering the function f of x equal to negative 3x squared. We're going to start by graphing this function. It's likely that you may already be familiar with what this function looks like on a graph. The graph of x squared is a parabola shape opening up, and then with the negative 3 up front, the negative is going to flip it over the x-axis and the 3 is going to stretch it vertically by a factor of 3. But what we can do is we can create a table of values, picking different x values and plugging them into the function. For example, if we take negative 2 and plug it in for x, we have a negative 2 squared, which is 4 times a negative 3, which is going to give us a negative 12. And we can do that with a handful of values here. Next, we'll plot these points on the xy axis. So I'm going to begin by plotting the point negative 2, negative 12, and then negative 1, negative 3, 0, 0, 1, negative 3, and 2, negative 12. Okay, next we will connect these points. And then after connecting the points, we now have our parabola shape for our graph of our function. Next, what we're going to do in part B is graph tangent lines to the graph at the points whose x-coordinates are negative 2, 0, and 1. Now a tangent line only touches the graph at one point. So the idea is that at x equal negative 2, when we graph that tangent line there in red, it's only touching the graph of the function at negative 2. Same thing at 0. That tangent line there is only touching the graph at x equals 0. And then also at 1. The idea is that it's only touching that graph at the x value 1. Now our goal in this problem is to find out what the slope of these tangent lines are. These red lines, these tangent lines that we just drew, we want to know what those slopes are. So to find those slopes, what we need to do is first find the derivative. That's what the derivative will tell us. It'll tell us the slope of the tangent line. So in part C, we're asked to find f prime of x, which is the derivative, by determining the limit. So we're going to calculate the difference quotient. The difference quotient is f of x plus h minus f of x all divided by h. That's the difference quotient. And then we're going to take the limit as h approaches 0. And that's going to give us our derivative. So I'm going to begin by calculating the difference quotient. So f of x plus h minus f of x is going to look like a negative 3 times x plus h squared, that's f of x plus h, minus f of x, so minus a negative 3x squared. And then that's all being divided by h. So now we need to simplify this. So we're going to have a negative 3 times x squared plus 2hx plus h squared. That's what we get when we multiply the x plus h squared out. And then we have a negative or minus negative 3x squared, which is going to become a positive 3x squared. And then this is still all over h. Alright, now let's distribute the negative 3 through. So we have a negative 3x squared minus 6hx minus 3h squared plus 3x squared, all divided by h. Now if we notice here, the negative 3x squared and the positive 3x squared cancel out. So now this is going to look like a negative 6hx minus 3h squared, all divided by h. Now in the numerator here, we can factor out a negative 3h. So if we do that, we have a negative 3h. Factoring that out, we have a 2x plus h. And then still over h. Now notice here the h's cancel. So now we're left with a negative 3 times 2x plus h. Okay. Now we've simplified the difference quotient. Next, in order to find the derivative, we have to take the limit. So now we're taking the limit as h approaches 0 of a negative 3 times 2x plus h. Now in taking this limit, what we need to think of is what happens as h approaches 0. As h gets really, really small, approaching 0, well, that's kind of going to go away. We would be thinking about, in this case, adding a small quantity to 2x. So as that gets smaller and smaller, it's essentially 0. Okay. So now our limit looks like -3 times a 2x, which is a -6x. So that is our limit of the difference quotient. And keep in mind that the limit of the difference quotient gives us the slope of the tangent line. So now we can use this f prime of x, -6x, to find the slope of a tangent line at a given x value. So now in part D we're asked to find f prime of -2. So using our f prime of x formula here from part C, we can find f prime of -2 by plugging -2 into our derivative. So we have a -6 times a -2, which gives us a +12. So the slope of the tangent line at -2 is equal to 12. And then finding f prime of 0, plugging 0 into our f prime, we have a -6 times 0, which is 0. So the slope of the tangent line at x equals 0 is 0. Now f prime of 1, plugging 1 into our derivative there, we have a -6 times 1, which is a -6. So the slope of our tangent line at x equals 1 is a -6. Now if we go back and look at our graph in part A, at x equal -2, if we look at the slope of that tangent line there, the slope of that line is 12, because we found the derivative at -2 is 12. And then at 0, when x is 0, if we look at the slope of that tangent line, notice it looks like a horizontal line, the slope of that line is 0. And then at x equal 1, if we look at the slope of that tangent line at x equal 1, the slope of that line is a -6.